those of you in Singapore who have read the news that there's potentially a demerger, but that's only going to happen a couple of months later. Looking at our growth and our focus, actually, we are looking at a sustainable portfolio of thermal and renewable energy assets. So our main focus is actually to originate, to own, to invest, to operate, and to optimize, and ultimately to hold and grow the platform that we built. The type of assets that we are looking at in today's context is a balanced one. We used to invest in coal, but we have stopped doing that. So we are really looking at growing our renewable portfolio and also sustain the gas portfolio growth. Up to now, we are actually one of the largest homegrown international renewable player in Singapore. We have more than 2,800 megawatts of renewable energy capacity. A lot of it is in wind in China and in India, but in Singapore, we are growing slowly and steadily. In Singapore, currently, we have about 246 megawatt peak of contracts already signed. In India, we do have a bit of solar, 35 megawatt, and we are looking at growing this solar portfolio in the next few years in the region as well. We also have energy from waste in Singapore as well as UK. Here are some of our achievements in the last couple of months where we are signing contracts with large solar installations. If you try to look for Singapore in the map, actually you can't see it. It's smaller than a dot. So to sign rooftop deals that are size of 6 megawatt, 8 megawatt, 9 megawatt is really, to me, an achievement, because such rooftops is hard to come by in Singapore, and Sembcorp has got quite a couple. As you can see, we signed a contract with SIA and SIA Engineering. Cash Logistics, UBS has signed a green power purchase agreement with us, and Capital Land also has got quite a bit of buildings, and the project with Capital Land actually helped us cross the 350 megawatt milestone in Singapore. And also the one on the right, where we are building quite a bit of HDB blocks. So HDB is residential buildings in Singapore. We are targeting to power up 1,500 buildings by Q4 2020 with our esteemed customers, as you can see in this. So we are really looking to grow a lot of rooftop solar in this little island in Singapore. Whilst rooftop is growing, the land in Singapore is very scarce, and even the building on the roof is contested. We have people trying to do urban farming, recreation, and all that. So there's really very little space left for rooftop. As of today, we have about 500 megawatts in total already signed and planned for construction. But Singapore is looking towards 2 gigawatt of capacity. How do we do that? Just by building on the rooftops where everybody is trying to contest the space. So then it comes to the next part, which is the main gist of our presentation here today, right, on floating solar. So other than looking at rooftops, Singapore is also looking at other ways to install solar, and of course we look towards the ground as well as the floating solar. And in February this year, Sembcorp was awarded the 60 megawatt peak project by PUB, which is the primary off-taker. So this deal is actually a 25-year power purchase agreement with PUB. In addition to solar, we also take on the retail energy and sell them retail energy for the night load. For this particular installation, we are having about 146,000 solar panels on, there's food grade solar panels on the reservoir. It should be able to meet the daily needs of PUB's 5 local waterworks, which is 7% of its total needs for the day, and at night we will power it through conventional energy. This will be expected to reduce carbon emission by 32 kilotons per year. So the previous presenters, Fatima, Yuji, San, has spoke about the benefits and the risk. So the benefits, I think it's quite quite common, but in particular to the floating PV at Tengeh Reservoir in Singapore, I think the reduction of water evaporation is a very good benefit for us. Of course, the algae growth reduction also makes the water better quality for us, right? In terms of risk, long-term reliability risk, the yield approximation, the lifetime cost of the floating solar, the operations and maintenance quality, the electrical safety and long-term reliability of the system and its components. All these are extremely critical and risks that we really need to take a deep look at so that we do not endanger the water quality at Tengeh. At the same time, we also keep the quality and the promised yield that we want to deliver as promised. So moving on to the market outlook, the installed capacity based on the recent study that's being done is at 1.8 gigawatt, and we are expecting this to grow very fast, and there is a high potential in Asia to reach the terawatt peak range. So I'm excited to see this growth, and hopefully with the experience that we get in Tengeh Reservoir installation, we are able to also develop more floating projects in the region for Sembcorp. Okay, so focusing directly on the risks that we are seeing at Tengeh Reservoir is mainly the four main areas: safety, design, performance, environment, and quality. Safety risk, as you know, this installation is on water, and electrical safety is one of the key concerns. Of course, high wind speed also may cause floats to break, anchor mooring system to give way. So we need to make sure that proper cable management techniques is done, extremely stringent quality and construction controls, design that takes into all these considerations. We are also planning to install sensors that use GPS type of trackers to give us pre-warning if there's two major movement, and of course ensuring design compliance right from the start of engineering design till the plant is constructed. We are looking at various stages of quality assurance. Unfortunately, for floating projects, there's a lot of bird droppings. That is a big headache for a lot of the developers. So excessive soiling is one of the issues that we face for floating due to the bird droppings. So this can cause unnecessary energy yield reduction. So we need to look at ways to avoid this soiling. At the same time, also have a good review of the design and analysis of the yield estimation. Environment is probably one of the most talked about and major concern, because we are actually building on a reservoir for fresh water. So biodiversity impact is one of it, but the water contamination, water quality control is one of the very critical controls that Sembcorp has to abide to, as well as the concern of all Singaporeans. So a full-scale EIS study has been done, and environmental control plan has been put in place before construction starts, and all the way for the 25 years of the operations and maintenance of the plant. Last but not least, the quality, where the mooring and anchoring wear and tear, the rusting of the metal parts, and the durability of the floating equipment is also a key concern. So we need to ensure the selection of the material is done well without compromising on the quality. The rigid O&M schedule has to ensure proper preventive maintenance rather than corrective maintenance. And also the supplier and contractor track records was one of the critical decision factors for us, as well as for PUB when they were actually awarding the contract to Sembcorp. So this brings me to the end of the presentation. I think it's more fruitful if I take questions and have an interactive discussion with all of you, the participants.
Yes, thank you, Jane, for your kind address. And we are very excited about the latest achievements of the Tengeh project. And again, congratulations.
Thank you.
For the questions now, I think we have 7 questions for prepared from the solicited questions and 2 in the open panel. So let's start from the first 7. What are the main characteristics? Is 2 gigawatts solar deployment target by 2030 in Singapore achievable? And how extensive reach of floating solar be relevant in Singapore?
2 gigawatt deployment in Singapore is actually possible, I would say. To date, we have about 500 megawatts of contracts signed between ourselves, the other company, Sunscape, and a lot of other solar developers, and more interest coming in. Based on the reasons, there's also land projects, more solar nova programs coming up, and 2 gigawatt is highly achievable. I think there's a recent study that is being done by led by Ceres that we have 36.8 thousand hectares of land, 36.8K thousand hectares of land to do solar, and that translates to about 8.6 gigawatt by 2050. That includes the land space. So by 2030, I think that is possible, highly possible, and we are working towards that. In terms of floating, we, based on the recent studies, we see that there is 250 hectares of inland reservoir and another 210 hectares of near shore net space that we can use for floating. This could translate to a possibility of close to 1 gigawatt by year 2050. So I think this is achievable, but we need to also look at BIPV, the facades of the building, and different kinds of new innovation and technology. Just by the traditional ground mount and rooftop, maybe not. Yeah.
And in terms of the floating solar opportunities sizing up, how do you think of the market openness to international developers, not only the Singaporean companies?
I guess at the end of the day, it's the quality and the price that matters, right? So I think whether you're local or international, as long as you can bring value to the project and make it a good quality project, I wouldn't see what's the difference between local and international.
And question number 2, how can floating solar compete with land-based solar given its higher capex cost? And how much more expensive is the EPC cost compared with ground-mounted ones?
Actually, ironically, at the current moment, we don't see a major difference. Of course, the floats are a little bit, the floats are more expensive than the mounting structures that you see in a typical project. Floats by itself is more expensive, and transporting the floats, I mean, it take up so much space in the container. So if you're in a country like Singapore where you have to import, the transportation cost is actually quite hefty. But we don't need to do land preparation. I mean, the water is just there, just launch it onto the water. So you save on the land preparation costs and a lot of all those soil preparation costs, land preparation costs, and all the compacting and all that. So we don't do that. So it's sort of like nets off. So at the current moment, we don't see a major cost difference. Slight difference because of the non-scalability of floating. I mean, the floating solar is currently not like in mass scale like the mounting structure. So in terms of the production cost and the cost of the floats are definitely in today's context more expensive. But as we grow the industry, and when there's economies of scale and there's a way to transport these things at a cheaper price, I don't think there will be a difference in the EPC capex cost for both land or floating.
Yes, I totally agree with you. Competition finally will reduce the price down. And question number 3, what are the common challenges in floating solar and the specific challenges in Tengeh project?
I guess floating solar, I mean, the usual things that you see in literature, in presentations, what everybody will say is the electrical safety, the anchor and mooring, the stability of the system, and of course the contamination of the water. Electrical safety is because is humid and it's moist and you come in contact with water, right? That will result in fire if you're not careful. So that is applicable for all kinds of floating as long as electricity and water, the two don't mix. So that is the issue. But specific challenge in Tengeh actually really is the water quality. I mean, that's where all Singaporeans drink water from, right? So any contamination is going to be a major disaster to the residents of Singapore. So the stringent, or rather extremely stringent controls on the water quality, the different kinds of measures that we need to do, the different kind of aerators, quality measures, measurements, monitoring, whatever you have it, we need to be responsible and accountable and really work on it for the next 25 years, because we cannot, even as a Singaporean, I'm not willing to compromise the water quality for the project. Yeah.
Yes, and the number four, always a sensitive question in number four. So PPA trend for a floating solar project, and what's the main criteria to Sembcorp to get financier and to get financiers' confidence, and to create confidence investors as well when developing large-scale floating projects?
I guess PPA, whether it's a rooftop, whether it's a ground mount, whether it's a utility scale, whether it's a small scale, whether it's a floating, it's all the same. At the end of the day, the financier wants his money back. So it's all about bankability. So for floating in particular, like the previous presenters mentioned, the technology risk, is still nascent. People are still looking at the evolvement of the technology perspective of it. Can the floats really last for 25 years? Will it sink? Will it burst? How will it affect the water quality? Will there be fires again? We have seen fires around, small fire, big fire, all these electrical safety. Will people dare to put the money on the table to invest in this and sign a long-term PPA? So these are questions that is always on our mind. So I think as we grow and as the industry become more mature, we will have like when we go and do due diligence on a typical land project, we know what exactly to look for in the due diligence for land. So I think this will be developed in the next 2 to 3 years for floating solar, and it will be no different from any other kind of PPA. As long as you have mitigation, as long as you have a quality control, it will be bankable and financiers will be confident in investing.
Well understood. And for question number five, I think it has been already addressed during your previous presentation. And for number six, may you kindly address, how is Sembcorp planning to deal with the end of life solar PV panels? What happens when they lose their effectiveness?
Yeah, actually, 1 or 2 years ago, Singapore Poly, which is a higher learning institute of Singapore, actually they approached Sembcorp to partner us. What they are doing is actually they recycle the solar PV panel, and they are able to recover 90% of the material. So we actually signed this collaboration with Singapore Poly, and we will support them in commercializing this. So if we are able to recover the glass, the silicon, the paste, which is the silver paste, all these are actually very valuable raw materials. We sell them for money and then we put in new panels. So this is already an ongoing collaboration, and in fact the Singapore's agencies have actually approved this this initiative, and also making some investments for the prototype. So hope if this goes through, then we will be recycling the panels and selling the raw commodities for money, and then after that, investing in new projects. Yeah.
And one last prepared question: how does Sembcorp plan to monitor the solar floating projects and ensure on-site safety? I think that's a similar question with the one in the open panel. They use a case in Japan. Just give me one second. Yes, sorry, just give me 1 second. It's not like on-site safety, but more like your response to the extreme weathers. So one question from Mr. Ramon Marcos Pernia: How do you handle force majeure events? How do you mitigate natural disasters? For example, the typhoon that hit Japan and wrecked a floating solar farm. So how to ensure the overall consistency of the project and outside safety as well?
Well, for the kind of disaster that you have experienced in Japan, I hope we don't see that in Singapore, because the waters in Singapore is actually quite calm, and it's very seldom we have extreme weather conditions. But that doesn't mean that we don't do any safety measures, right? So like I mentioned in the presentation, it all starts from the design stage. You need to look at all the previous weather conditions and simulate it and be prepared for it. So the anchor and the mooring design is crucial, because once it's snapped and then things get exposed to water, electricity and water, they don't mix, and then you have this kind of disaster. So having said that, of course, if there's a major typhoon in Singapore, I'm not sure if we are able to handle that. But if you're talking about extreme weather conditions, extreme rain, and due to the high buoyancy of the solar panels, I'm sure the floats at some point over time will drift and they will go out of place, out of position. So we are deploying digitized trackers so that we can monitor not only on site, but when we are at home, we have beepers alarms to beep us and tell us that it's out of place, and we need to go and fix it back. So we are embarking. I mean, we already have a digital system that we monitor all our assets, and I mentioned it starts from pre-design phase, where you really look at how your cable will move, you simulate it based on the wind speed that you have, and all these things has to be pre-designed and make it mistake proof. Of course, when you need to implement those digital tracking and trackers so that it can prompt you if your things are out of place. But for the extreme typhoon condition, I mean, to tell you that I'm able to manage it, I think that's probably not truthful. So as of now, we have already looked into the extreme weather conditions to the extent that, what Singapore has encountered in the last 20 years.
Mm-hmm. Well understood. And I know that due to the agreement with PUB, you are not able to disclose a lot of information related to the commercial part of the Tengeh projects, but this one would be general. So Ms. Jen, based on your own experience, how are operating expenses for an FPV project compared with typical ground-mounted facilities? That's a general one.
It's general. Yeah, it's quite general. I think I just give you an example. In Vietnam, right? I mean, when I visited the large scale ground mounted utility, you actually move around in a car or in a truck. In floating Tengah, you need a boat. So the cost of the maintenance of the boat is definitely more expensive than the car, right? You can run around in the ground mount, but in in the floating, I don't think you can run around because there's a danger of falling off. So maintenance, I'm sure, is more expensive on the floating, and that's just for manpower and logistic support. If you talk about frequency of maintenance, frequency of cleaning, I'm sure floating is also a little bit more because of bird dropping. Somehow is very excessive. And also, like I said, all the electrical safety, cable management, we can't just ignore it. You really need to go and do preventive maintenance. So frequency again is small. So I would foresee about 10 to 20% minimally operations and maintenance costs. Of course, in terms of parts durability, the breakdown of the hardware, maybe floating is less because